So we were discussing about RDR.
आणि तिथून किती तसं काय ना ग तो ह्यो कधी तो कसं एकटा होतो एकटा जोडतले किती भागून पण जातो कोण तुका सांगा दौडून ना म्हणून कोण असं म्हणा का म्हणता दौडून ना म्हणून तर पळयता उलयता आमच्या कशें आसता जाणा तुका जाली पत्रिका म्हाका आमी हेच्यान पयलीं केन्नाच म्हळ्या ताणे कडेन
So let's go to the video. It doesn't mean that here also VRFs should be same. Name could be different. Okay, people have this misconception also. From here to here, MP-BGP, and we'll put all the possibilities. Suppose I am running static here. Suppose AGRP here. Static. OSPF. AGR. And what you have to do here is redistribute. So by step you get an idea actually what you are going to do. Whatever routing protocol you're running, fine. Now in the VRF we have, I'll write it down for this side. RD we have given 100:1. Now a different variant I'll show you for RT also, but right now I'll make it yesterday's concept RT. Export could be 100:1. Import 100:. The RD could be same 100:1. RT. Export will be 100:2. This import will be this export. Import will be 100:1. Right. Now here RD 100:. RT, it could be like this also. Export, you can write 100 colon 3. Import 100 colon 3. Same, locally significant. You can write this command in different way also, I'll tell you on the other side. Here, RD could be 100 colon 3. RD, you can write a command called both. With both import and export is 100 colon 3. This is also, you get that. Okay, so make a note, this possibility could be. One more time, I'll make a flow, and then I'll explain you the other part of. So when, suppose this is your and this is your overlap. So then this guy will send an update. Send me like n.1.1.0 100 colon 1 VPN and RT export 100 colon. Similarly, when packet will reach here 100 colon 3 RT 100 colon. Similar way, packet will come out of this 100 colon 1 and RT will be 100 colon 2. Similarly, when packet will come out of this 100 colon 3 upon RT will be 100 colon 3. One second. Okay, so this much you are aware. Now, with a control message, one more thing will go out. Okay, so I won't make that many things to confuse you. Right now, I'll just make a straight away. This is export. This will be export RT. Export RT. Okay, import will be on the other side when it will reach here. This will be imported here because of 100:1. This will be imported here. When this will reach, this will be imported here. And this will be imported here. Now this is your half control message. One thing was missing. So I gave you an idea like you can run 3 to 3 different routing protocols. Why MP-BGP is required. Okay, now step by step you're getting an idea. Okay, now I'll make one more topology where I'll make, I won't write all these things, redistribution, all those things. I'll write RDRT now third label also. The complete structure I'm making. A little bit complicated, but could be easy if you understood the. So far, I'm just repeating the thing so that that concept should go inside your mind. So right now, I'll take only single one for your understanding. Then I'll take two different for your so that you'll understand. So suppose this is VRF. This is also VRF. Now, when he will going to send that, RD is here 100:1. RT export 100:3. Import 100:5. Here RT is 100:1 and RT export is 100:5. Import is 100:3. Okay. So now one more concept is there. It generates something called its own VPN label. It shares actually. Suppose I will say 19. Here they generated. Now VPN label is again an attribute of VRF 22. Generated. Okay. Right now, it just generated. If you will check, like if you remember, a packet hit a PE router, it will check show IPsec and where you want to go. For like for a push, a single your label will be there. This time two labels you will see. Practically, I will show you. But before that, let's try to understand. Suppose this is a network. Now I'll complete the update. How actually it will happen. Packet will go here. $100:1 and export RT. No need to write now. I'll just write on RT. And your own VPN label will also be exported. Okay. Now, it's like a public key exchange in IPsec, you remember. Here also, this guy will exchange 100:5. $100:1, sorry. Okay. And RT will be 100:5, and VPN label will be 22. See, we are not generating anything. We are manually typing these. It is automatically generating by VRF. Okay, make this a note. Okay. So now what will happen? Same concept. Now this is where we are talking about control message. Control packet. Okay. So first I will explain you this much, and then I will make a scenario where to VRF, and then hopefully you'll understand the concept. Now when again, because of this export import, it will go here. This guy will go here. That concept you're aware. Now actually what will happen? Suppose I will now see your control packet. Now after that, now I'm making down data packet. Now this is very important. Just try to understand, and today write also with me. Okay, now what I was going to do, I want to write RDR, because when control data packet will go RD mode. You have two things. One is your own VPN label, which I will say 90. One you received, 22. Here also you have your own VPN label, 22. And what you received, 90. Now, what you receive, here it is little opposite. What you receive will become export. What you have will become import. First of all, you are exporting your label. You will say exchanging your label or exporting whatever. But after the exchange, this in the data packet, this will become export, this will become import. Same thing, the received one will become export, and your local will become import. Okay, I'll give you a chance to try it, but just see here now what will happen. When you're sending a data packet, okay, here you will check that command called show IPsec with respect to VRF. two labels will be there. Suppose one is label number 22, other will be normal label number 70. So it will be like this: 2 MPLS label 17 and 22. Now this label is used for that push, swap, pop, and this label is used for to which VRF you belong. It is doing same functionality what RT is doing in the control message. Here in the data packet, VRF is doing to which VRF you belong. Okay, same way this guy will initiate a packet. So show IP self. One label will be 19, other label could be 19, but I don't want to confuse this. I'll make 32. So here one is 32, one is 19, and again one more thing. Bottom of stack is 0, where bottom of stack is 1. Similar way, bottom of stack is 0, bottom of stack is 1. Wherever I put bottom of stack equal to 0, meaning we will do push, swap, pop. Bottom of stack equal to 1 means will tell you to which VRF you belong. So now you need to understand, once it will reach here, this will be pop, but with the help of 19, see this, import 19, VRFA. It will go here, this will be pop, and 22, import 22. So this is your data packet. Okay, I'll give you 5 minutes, just go through this. Okay, I'll make a one big topology, and again, final setup I'll do. Just do it. Then one more lookup is there. While that I'll show you while practical only. So I'll give you 5 minutes and go through. It is important. Okay, I hope that is clear. I'll make a final topology so that overall review will be there. So control and data packet, this will be very important because one second, I can make it in a same page, both control and data plane, so good to for understanding. RD won't come here. Here RD and RT concept won't be there. And here VPN label is carried by your RD only. That when that update will go for PGP. Okay, all Wireshark capture everything I'll show you. So now let me make it here. Control packet. VRF, 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 VRFP. Okay. So RD 100:1, RD 100:2, RD 100:3. Again, remember again and again, I'm telling you, RD value we have to write, but we can label it operate automatically by VRF 100:. Now RT, we can write this command also both. So I'll use this shortcut 100:1 on the both side. Here I can change also. Here also let me write RT both. Hundred colon one. Import export both. Okay, one side. Okay, here I will change export hundred colon three, import 100:5. RT export 100:5, import 100:3. Then we can label. VPN label 19, VPN label 22, VPN label 24, check, 32, then VPN label 39. Okay, so sort of updates I have to create. So when a control packet will go out, I'll make it 10.1.1.0, 10.1.1.0, 40.1.1.0, 40.1.1.0. Okay, so control packet will go like this. Now 10.1. You can also make if you want. 100:1 will be RD, and your RT will be export and import, both are same, 100:1, and VPN label 19 your set. From here, an update will go out 10.1.1.0, 100:2. RT will be export 100:3, and VPN label 32 will go out. Similar way, an update come from here 40.1.1.0, 100:3, and RT will be 100:1 because both are same, and VPN label is 22. 40.1.1.0, 100:4, RT 100:5, VPN label 39. Right. So accordingly, they will be imported. That you understood. Now I'll make a data packet here. try to cover this here itself. This is BRF A. BRF A. BRF B. Okay, so again, I'll just make a note only VPN label. So one is my local, I will write so that no confusion. Local VPN label. Local VPN label, local will be 19, which is acting like an import. The remote I will write here, what you receive VPN label is 22, which will become export. Okay, or you can say it will push it. So I'm just putting my own terminology here. And again here I'll say local VPN label is what is what it is here, 32. It will become import. The remote VPN label is 39, which will become export. Local VPN label is 22, which will become import. Remote VPN label is 19, which become export. Local VPN label will be 39, which become import, and remote VPN label is 32, which will become export. Now, one more thing I will let you know after this, but first of all, let me complete this. As you understood now, what will happen when this guy will send a packet. So in IPsec table, two labels will be there. One label, suppose, is 17, other will be 22, right? When this guy will send, one label will be, suppose the first label could be anything. It could be 17 again and 19. So bottom of stack is 0, bottom of stack is 1. Now in the last example, whatever I have wrote, same follows. Here be like 24 first, and other is export is 39. Packet goes out of this. First could be 25, second could be import, export will be 32, right? So when this will reach here, this 22 will tell him import on BRF. When this will reach here, the 39 will tell him to import in, yeah, this one. When 19 will reach here, it will tell them import here. And when 32 will reach here, import here. So data packet controlled by. I hope it is clear. Now, one more, I'll tell you one more thing. So practically I'll show you, but here this is BRF table and here it's a global table. Okay, I'll tell you practical. Okay, so that next stop and all those things should be proper. According to the scenario, few more things I have to discuss. But tomorrow what we'll do, I'll start off with the practical. So let's see how much we're going to complete practical also, because we'll do step by step. First practical will be very slow. Second thing, what we'll do is 4 BGP in one day I'll teach. Again, one more is there, sham link, that also I will complete fast. But this first practical will be very important for you. Okay, today I'll stop here. Tomorrow we'll continue with practical.